I lost my pen. Oh, where'd the pen go? So we're going to move on to section 3.2, which is factoring quadratics and extracting square roots. So the first thing we have to remember is that we've already learned about this. We've already learned about linear equations. This was the slope-intercept form of a linear equation. Notice that its x value is raised to the first power. Now we're going to go to quadratic equations. To me, quadratic seems opposite of what it should be. Quadratic seems like 4, like a quad means 4, but that's not what it means. This is our quadratic equation, and I see that my highest exponent value is a 2. So it's not raised to the fourth power like it seems like it should be. This is our general form of a quadratic. And when you graph a quadratic, it looks like this. We can have it open up like this. We can have it open down. That's what a quadratic looks like. It can cross the x-axis or not cross the x-axis. So that's just a reminder of what they look like. And we've drawn them several times with our parent functions. So to solve a quadratic, like we solved a linear, that means that we're going to set y equal to 0. So here's y. We're going to plug a 0 in for that. And then find its solutions. So when I solve, I'm finding solutions. I'm finding the roots. I'm finding the x-intercepts. I'm finding the zeros. These all mean the same thing. These all are the same. So when we're solving a quadratic, let me draw a picture again. If I am finding its x-intercepts, that means where it's crossing the x-axis. So in this picture, right here, it's crossing the x-axis in 2 places, which means I'm going to have 2 solutions, right? If I go to my parent function, which is right here, here's my parent function. It's only touching the x-axis in 1 place, so I'm only going to have 1 solution. Here, this blue one is not crossing the x-axis anywhere, so there's not going to be any solutions. So our solutions that we're talking about here, they're in the real number system. The real number system is any number that you can possibly think of in the whole entire world. Someone today in my other class said, so if those are real numbers, then what are the fake numbers? So the fake numbers are the complex numbers, and we're going to get to that later. That's what happens when your quadratic does not cross the x-axis. So if your quadratic look like this, there are no real number solutions at all because it's not crossing the x-axis. So that's when we would have complex solutions. Okay, so let me focus back up here at this 2 again. This 2 tells me, since that's my highest exponent value, that I can have 2 solutions. 2 real number solutions, 1 real number solution, or 0 real number solutions. This 1 on the linear tells me that I'm going to have 1 solution. If I'm dealing with more than one linear equation, I could have 1 solution, or let's not talk about that. Never mind. I said that. Okay. So what we're going to do today is factor quadratics. If you cannot factor quadratics, I'm telling you the God's honest truth right now. If you do not learn how to factor quadratics, then the rest of this course is going to be downhill from there. You're not going to be able to do any of it. So if you absolutely hate this math and you think I'm just going to, wait till the last minute and do whatever I can and it'll be okay, I'll be able to pass it, you're not going to, because everything after this uses solving linears and solving quadratics. And you have to do that over and over and over and over again. So make sure that you learn how to do this. Okay, so factoring a quadratic, we said that we're going to take our quadratic, instead of having a y here, we're going to set it equal to 0. And I want to find out how to factor. So I'm going to write this set of rules. Before we ever do anything. The first rule is to find factors of A times C that add to B. So when I'm talking about A, B, and C, I'm talking about these coefficients here. So whatever these numbers are right here, A and C, I would multiply them together and then find the factors of that product. And then I would take those factors and see which one of those factors add together to be B. The second step is to write the quadratic as linear factors. So it could look like this. X plus something, X minus something. You could have a number here. There could be something there. There could be something there. I don't know. But it's going to be a set of parentheses with X and a constant, and X and a constant with plus or minus or numbers. Step 3 is you're going to set each linear factor equal to 0. And solve. This is called the zero product property. The zero product means multiplying, means that if you multiply 0 times anything in the whole entire world, doesn't matter what it is, you're always going to get 0. So if one of these factors is 0, then that's going to be 0, which is why it's going to equal 0. Now here's our example. So I have x squared minus 2x minus 8 equals 0. It's already set equal to 0, so I don't have to do that. I have it in general form, which means that I have the exponents in decreasing order. Here's a 2, here's a 1, there's my constant term. So now I'm going to write down what my coefficients of the quadratic are. So in front of this x squared is a 1. This is a negative 2. You can't forget the sign. If it's positive, you don't have to write positive, but if it's negative, you need to write negative. This is negative 8. So now I'm going to follow these rules. It says find the factors of a times c. So let me write a times c. What is a times c? A is 1 times negative 8. 1 times negative 8 is negative 8, right? So the factors are going to be 1 times negative 8, negative 1 times positive 8, 2 times negative 4, and negative 2 times positive 4. I kind of wrote that a little backwards. If I multiply a times c, I get negative 8. So now I want to add those together to equal b. B is negative 2. That's what this says right here. Add to b. When I add 1 plus negative 8, I get negative 7. That is not equal to negative 2. So that's not going to be it. Negative 1 plus 8 is positive 7. That is not equal to 2. So that's not going to be it. 2 plus negative 4 equals negative 2. So that is it. These two factors are the ones I'm going to use. So I know this one's not going to be it. That's going to be positive 2. So I'm going to write the quadratic as linear factors. And I'm going to put this is positive 2. This is a negative 4. So I factored this. Next, it says set each linear factor equal to 0. So I'm going to take x plus 2, set it equal to 0. Take x minus 4, set it equal to 0. So what do I plug in here to make this equal to 0? It's going to be negative 2. X is going to be negative 2. If I subtract negative 2 on both sides, then if I subtract 2, then I get x is equal to negative 2. Here, I'm going to add 4 on both sides. X equals 4. So those are my two solutions, or my two x-intercepts, or my two roots, or my two, zeros. So at x equals negative 2, the quadratic is crossing there, and at x equals 4, it's crossing there. This positive 1 right here tells me that it looks like this. So my quadratic looks something like that. Next, we're going to move on to what happens when my leading coefficient is not 1. So here my leading coefficient was 1. The leader is the one that's attached to the highest exponent part. So when my leading coefficient is not 1. So looking at this, I see that it's set equal to 0. I do not have a constant term here that's not 0. So I'm going to look at it like a fifth grade math problem, and I'm going to find the greatest common factor. So the greatest common factor of 6 and 3 is 3, and the greatest common factor of x and x squared is x. So now I'm going to say 3x times what equals 6x squared? 2x minus 3x times 1. So I have two linear factors here. When you don't have a number here that's non-zero, then you end up with 3 times x, or a number times x, and then a linear factor. I'm going to set them both equal to 0. I'm going to divide both sides by 3. Here I'm going to add 1 on both sides and divide both sides by 2. So I see that this quadratic is crossing the x-axis at 0 and 1/2. So it would look like this. Crossing here, let's say that this is 1, this is 1/2. This number tells me it's positive, so it looks like this. That's what it looks like. So finding the greatest common factor, if there is one, is a good way to solve these. So if you look for one and you say, oh, they have a greatest common factor, then you don't have to do all of the other stuff. I could have done all the other stuff with this. I could have, but I don't have to. Okay, so now we're going to move on to a coefficient, leading coefficient that is not 1. And we're going to follow the same rules that we did up here. The rules are exactly the same. The first rule says find the factors of a times c. So let's write down what a is equal to, what b is equal to, and what c is equal to. A is 3, b is -4, c is -15. So a times c, 3 times -15, that's -45. These factors have to add up to b. B is -4. That's what this says right here. Oops, right here. So I know that I have factors of 1 and -45, and -1 and +45, 3 and -15, and -3 and +15. But I know none of those are going to add to -4. They're just not. 3 and -15 add together to be -11. So I'm going to go to 9 and -5 and -9 times +5. Those are also factors of -45. When I add them together, 9 plus -5 gives me +4. -9 plus +5 gives me -4. So that means these are the numbers that I'm going to use. So when I have a number that is not 1, then I'm going to do factor by grouping. So I'm going to take this equation. Let me rewrite it so I'm not over here in this business. And what I just found right here were factors of a times c that add together to be b. So I'm going to take this b term and I'm going to rewrite it with a -9 and a +5, and I'm going to add an x on it. So I'm going to say 3x squared minus 9x plus 5x minus 15 equals 0. So this right here is the same thing as this. And I got those from here. Now I'm going to draw a line right here down the middle. And I'm going to group these two together. I'm going to group these two together. That's where you get grouping. You can't forget that there's a plus sign right here. Now I'm going to look at this first group, and I'm going to find the greatest common factor of the first group. What is the greatest common factor here? 3x. 3x times x equals 3x squared. 3x times negative 3 is negative 9x. Now I'm going to put my plus sign right here. Now I'm going to do the same thing with 5x and negative 15. What is the greatest common factor of 5x and negative 15? 5. 5 times x is 5x. 5 times negative 3 is negative 15. So once you do that, you should see in parentheses you have something that's the same. This is a greatest common factor. So the greatest common factor was used here, it's used here, it's used all over the place. So I'm going to take that greatest common factor and it's going to be multiplied by what is left, 3x plus 5. Those are my linear factors. So right here it said set each linear or write as linear factors. There they are. So that's step 2. This was step 1. Now I'm going to do step 3, which is to set them equal to 0. I add 3 on both sides. I'm going to subtract 5 here. Now I'm going to divide by 3. These are my two x-intercepts for this quadratic, 3x squared minus 4x minus 15. Oops, I have no idea what I just did. That's factor by grouping. Now in your resources for this, let me go to that page and show you. Right here, I have other resource videos that show you what to do. If you're used to doing the box method for factoring, that's the same thing that we just did, except you just write it out in a box. It's right here. Here's another video of factor by grouping. Here's extracting the square root, which we're about to do, and then using the greatest common factor. So there's other videos there that will help you. Okay, so let's do another one. Notice that this one that is not set equal to 0. So I need to move this over. So I'm going to subtract 3 on both sides. I get 2x squared plus 9x plus 4 equals 0. So I'm going to go through the same process that I just went through. Step 1. Oops, let's write our A, B, and C. A is 2, B is 9, and C is 4. Step 1 says to take A times C. A times C is 2 times 4, which is 8. CF, you can find the factors that are going to add to be b. B is 9. So these factors are 1 times 8. That's really easy because 1 times 8, 1 plus 8 equals 9. So I found that already. These are going to be my, how I'm going to rewrite 9x. So I have 2x squared. I'm going to have to erase this because I have a hot mess going on. So I had 8x plus 1x. That equals 9x plus 4. So all I did is rewrite 9x as those two factors that we found when we followed the step 1 rule. So now I'm going to group the first two and then the last two. Once I group it, I'm going to find the greatest common factor out of each group. So the greatest common factor of 2 and 8 is going to be 2, and the greatest common factor of x squared and x is going to be x. 2x times what equals x squared? 2x times x. Plus 2x times what equals 8x, and that's a 4. So here, what is my greatest common factor of 1 and 4? Well, it's 1. 1 times x is 1x. 1 times 4 is 4. There's my greatest common factor of both of those. Now I'm going to take what's left and put it in the other set of parentheses. So here are my two linear factors. Now I set them both equal to 0. So I subtract 4 on both sides. I subtract 1. Divide by 2. And I found my two solutions. Y'all okay with that? Okay. Here's some more examples right here. You can do these examples. I'd, encourage you to. We're not going to do them, so we're going to move on so we can go home tonight at some point. So the next part we're going to look at for solving quadratics is extracting the square root. So the first thing you have to do when you extract the square root is to isolate the square. And the second thing is to take the square root of both sides. And the third thing is don't forget plus and minus. That means, for example, if I have x equals the square root of 4, what is the square root of 4? What can the value of x be that's going to be equal to the square root of 4? It can be positive 2, right? It can also be negative 2. So negative 2, I think I left off. What am I doing here? The square root of 4 is going to be negative 2. The square root of 4 can also be positive 2 because 2 times 2 is 4. Negative 2 times negative 2 is also 4. They're both 4. Okay, so let's look. So isolate the square. Here I have the square right here. It's isolated all by itself. And the numbers on the other side. Step 2 says to take the square root of both sides. The square root of x squared is x. So x equals plus or minus whatever the square root of 8 is. So you have to do the positive and negative of what that is after you take the square root. So we have to look and see if we can simplify the square root of 8. So I can do this several different ways. I can say, how can I write the square root of 8 using a perfect square? A perfect square is like 1 times 1 is 1, 2 times 2 is 4, 4 is a perfect square, 3 times 3 is 9, 9 is a perfect square. So if I can rewrite 8 using the perfect square of 4, I can do that. So multiplication inside of there means you can separate it out like this. Sorry, I should have put plus or minus. What is the square root of 4? 2 times the square root of 2. So this square root of 8 simplified is 2 times the square root of 2. So this is looking for perfect squares. You can also do a factor tree. So we would take what is underneath the radical sign and do 6th grade math. I take this 8 and I just write factors until I get prime numbers. So when I get to a prime number, I circle the prime numbers. Prime means they don't have any other factors. So 8 is the same thing as 2 times 2 times 2. So I can rewrite this. I'm going to come over here and do this. If you have 2 of the same thing, then it gets to come out of the square root as just one of them. Because 2 times 2 is 4, the square root of 4 is 2. So either one of those ways is fine. So I want you to notice when we're extracting the square root here, I'm able to isolate the squared part, whatever is squared. It doesn't just have to be one thing. It could be this. This is the squared part that I would isolate. So let's look at this one. I have 4x squared plus 1 equals 7. So I want to isolate the squared part. Here's my squared part. I want to isolate it. So I'm going to subtract 1 on both sides. Want to isolate this. So I want to get rid of the multiplied 4. So I'm going to divide both sides by 4. So I can reduce that fraction or I can not reduce the fraction. It doesn't matter right here really. So once I get this far, I can take the square root of both sides. The square root of x squared is x. This is going to be plus or minus, just like over here when I did the multiplication and the square root is over both multiplications, then I can write it like this. So I know that that's going to be equal to plus or minus the square root of 6 over 2, because the square root of 4 is 2. So that is what x is equal to. Now we don't ever want to leave a square root sign in the denominator. So if that comes up again, then we'll rationalize the denominator and I'll show you how to do that. Okay, so now I have 3 times the difference of x minus 4 squared equals 15. This is my squared part that I need to isolate right here. So I'm going to divide both sides by 3. And I get x minus 4 squared equals 5. Once I got that squared part isolated, now I follow my same rule that says take the square root of both sides. The square root of this means that that's going to cancel. So I have x minus 4 left on the left side equals plus or minus the square root of 5. So you have to remember this plus or minus when you're doing a square root or a fourth root or a sixth root or an eighth root. Any even root is going to result in a positive and negative solution. I want to know what x is, so I'm going to add 4 on both sides. This gives me 2 solutions, just like this was 2 solutions. These 2 solutions are x equals 4 plus the square root of 5 and x equals 4 minus the square root of 5. Anyone have any questions? Okay, so let's look at finding the length of a missing side of a right triangle. So this is geometry, but it's applicable because we just did squaring sides and taking the square root of both sides, and we're going to have to do that here. So in geometry, if there's one thing that you learned in geometry, it should have been the Pythagorean theorem. The Pythagorean theorem says that the square of the sum of the 2 legs, the legs are the parts attached to the right angle, is going to equal the square of the hypotenuse. The hypotenuse is the one opposite the right angle. This only works with right triangles. So here's A. This is going to be B. This has to be C. Every single time the side opposite the right angle has to be the hypotenuse. Every single time. So I don't know what A is, but I'm looking for it. So I have A squared plus B is 4, so I'm going to square it. C is 12, so I'm going to square it. 4 squared is 16. 12 squared is 144. So if I want to know what a squared number is, I have to isolate that squared part. Remember, that's the same thing that I just did. So I'm going to subtract 16 on both sides. When I subtract this, I get 128. Now I have to take the square root of both sides. I isolated the square, so I'm going to square root both sides. So A is going to equal plus or minus the square root of 128. Let's think about this before we deal with this business. Is it going to make any sense for this side to be negative? You can't have a negative length. You can't drive a negative amount of miles. So length is always going to be positive, so I don't even need to consider that negative value there. I only care about the positive value. So let's take what's underneath there, and I'm going to do a factor tree right now. So I have 2 times 64 I'm going to keep going, but what do I know about 64? Is 64 a perfect square? Yes, it is. Y'all are killing me not answering my questions. I'm just saying. Killing me. 2 times 32. Then I can do 2 times 16. And I can do 2 times 8. And I can do 2 times 4. And I can do 2 times 2. So I know that 128 is equal to 2 times 2 times 2 times 2 times 2 times 2 times 2. So let's look at how many pairs of 2 that I have. Those 2, those 2, those 2, and then one left by itself right here. I'm running out of room. So if I put this under the square root sign, if I have a pair, then that gets to come out as 2. If I have a pair, it gets to come out as 2. If I have a pair, it gets to come out. This has to stay under. So this is equal to 8 times the square root of 2. So A over here is equal to 8 times the square root of 2. So a minute ago when I was doing the factor tree, I said we're going to keep going, but what I saw quickly was that I had a perfect square factor. So I know that 128 is equal to 64 times 2. This is a perfect square. So finding the simplified version of the square root of 128 means that if I have a perfect square under the radical sign, it gets to come out as what is the square root of 64? It is 8. This gets to stay under the radical sign. I got the same answer. Okay. And that is the end of 3.2.